Remember that old game Snake? That simple one where you had to like guide this little line around and it would get longer every time you ate a fruit? Well, it turns out teaching a computer to do that is surprisingly hard.
It is.
But
And that's actually what we're going to be looking at today.
yeah, we're diving into how researchers are training AI to play games.
Not just Snake, though.
Right, we're going way beyond that.
To some really complex games.
Exactly like StarCraft 2.
And even Dota 2.
Oh yeah, Dota 2 is a big one.
It's a huge challenge for AI.
So to guide us on this deep dive, we have two main sources.
The first is a research paper.
Yeah, and it's all about how they trained a snake-playing AI agent.
And then we'll also be taking a look at this comprehensive review paper on something called multi-agent reinforcement learning.
Which sounds very complicated.
It is a bit, but don't worry, we'll break it down.
Yeah, we'll make it easy to understand for everyone.
Absolutely. So this first paper, it's really interesting because it uses SNCC as kind of a test bed
Oh, that makes sense.
to compare different reinforcement learning algorithms.
Now, before we get into the nitty-gritty of these algorithms,
Sure.
can you just remind us what exactly is reinforcement learning?
Oh, yeah, definitely. So at its core, reinforcement learning, it's basically like training a dog.
Okay, I like that analogy.
Yeah. You reward the behaviors you want,
Right. Give him a treat,
and you discourage the ones you don't.
like the little spray bottle or something.
Exactly. So in this case, the AI, it interacts with the environment, right? So that's the game.
Okay, the game is the environment.
Uh-huh. And then it takes actions like,
Uh.
moving the snake up, down, left, or right.
Oh, I see.
And based on those actions, it receives feedback
Okay.
in the form of rewards or penalties.
So if the snake eats a fruit,
Yeah, it gets a reward.
like a point or something,
Exactly. And if it crashes into itself,
it gets a penalty.
it dies, game over.
So it's a learning process.
Yeah, that feedback loop, it helps the AI agent learn which actions are good and which ones are bad.
And ultimately lead to the highest score. Okay, so back to our snake AI.
Yes.
You mentioned that they used two different algorithms.
Yes.
Double DQN and PPO.
Yeah, that's right.
What exactly is the difference between those two?
So they're both trying to do the same thing, right? Optimize the agent's actions to get the highest score,
Makes sense.
but they go about it in different ways.
Okay, so how does double DQN work?
So double DQN, it stands for Double Deep Q Network.
Wow, that's a mouthful.
It is, but essentially it tries to address a problem that traditional Q learning has.
Which is...
It tends to overestimate the value of certain actions.
Oh, so it thinks some things are better than they actually are.
Yeah. And that can lead to unstable learning.
I see.
So double DQN uses two separate networks,
Okay.
one to evaluate actions and one to select them.
Oh, so it's like a checks and balances system.
Exactly.
Yeah.
And that helps to reduce that overestimation and make the learning more stable.
Okay, so that's double DQN.
Now, PPO, that's proximal policy optimization.
Another really long name.
I know, right? But it's a different approach.
How so?
It focuses on making small incremental improvements to the agent's policy.
The policy being...
The policy is like the set of rules that the agent uses to make decisions.
Okay, got it.
So PPO, it's kind of like it's taking baby steps,
Okay.
trying not to stray too far from what's already working.
Interesting. So double DQN is more about like fixing a specific problem,
Yeah.
and PPO is about kind of fine-tuning the overall approach.
Yeah, that's a good way to put it.
So what were the results? Which one did better?
Well, it's interesting, actually. They both had their strengths and weaknesses.
Oh, really? Tell me more.
So the double DQN agent, it was more consistent.
Okay.
It averaged 10.4 fruits per game,
Not bad.
and its maximum score was 15.
Okay.
Now, PPO, it was a bit more erratic.
Okay.
It only averaged 7.89 fruits per game.
Oh, that's lower than the other one?
It is, but its maximum score was actually higher.
Oh, wow. What was it?
It hit 18.
Wow. That's pretty impressive for a game of Snake.
It is.
So it sounds like choosing the right algorithm depends on what you're looking for.
Exactly.
Do you want consistent performance, or do you want the potential for breakthroughs?
Yeah. It's a trade-off.
I'm curious, why do you think there was such a difference in performance between the two?
That's a great question. It could be a few things.
Like what?
Well, maybe the PPO agent was able to exploit some quirk in the snake environment.
Oh, like something the double DQN agent just couldn't figure out.
Exactly.
Interesting.
Or it could be something about the way the neural networks were designed.
Oh, yeah. Those are the brains of the AI, right?
Yeah. Or even the hyperparameters that they use during training.
Hyperparameters?
It's like all these little settings that you can tweak.
Okay, so even in a simple game like Snake,
Uh-huh.
there's a lot to consider when you're choosing and fine-tuning these algorithms.
Oh, absolutely.
But Snake is just one tiny part of the gaming world.
Right.
What happens when we move to games with multiple players interacting?
Ah, yes. Like those massive online battle arenas, the MOBAs.
Yeah, exactly.
That's where things get really interesting
I bet.
because you're no longer dealing with just one AI agent.
Right.
You have multiple AI agents all learning and adapting,
Oh, wow.
not just to the game environment.
But to each other as well.
Exactly.
That sounds insanely complicated.
It is. It's a whole other level of complexity.
So what do you call that when you have multiple AI agents?
That's called multi-agent reinforcement learning, or MRL for sure.
Meryl. Okay. I'll try to remember that.
Yeah, it's a mouthful.
So what are some of the challenges that researchers face when they're dealing with Meryl?
Oh, there are many. But one of the biggest is just the sheer vastness of these multi-agent environments.
You mean like the size of the game world?
Yeah, but it's more than that. It's the number of possible states the game can be in.
Okay. I'm not sure I follow.
So imagine like a game of chess.
Okay.
There are a lot of possible moves, right?
Yeah, tough.
But it's still a finite number.
I guess so.
But in a MOBA like Dota 2, the state space is enormous. The paper actually mentions it's estimated to be 10 to the power of 20,000 possible states.
10 to the power of 20,000. That's insane.
It is. For comparison, Go, which is a notoriously complex game, has a state space of only 10 to the power of 170.
Wow. Okay. That puts it in perspective.
Yeah, so you can see how MRL, it's a whole different ballgame.
It sounds like it.
Mhm.
So how do you even begin to design algorithms that can handle that level of complexity?
Well, it requires new approaches.
What kind of approaches?
The traditional reinforcement learning algorithms, they don't cut it in these vast dynamic spaces.
Why not?
They weren't designed for it.
Oh.
They're like trying to use a bicycle to win a Formula One race.
Uh-huh. I get it.
So researchers are developing new techniques,
Huh.
things like, efficient exploration.
So the AI can learn about the environment more quickly.
Exactly. And effective decision-making with incomplete information.
Because in a MOBA, you don't always know what your opponents are doing right.
That's right. It's like a fog of war. And then, of course, adapting to constantly shifting conditions.
Because the game's always changing.
Yes. The other players are making moves. The environment is evolving. It's a very dynamic situation.
It sounds like trying to navigate a city where the streets are constantly rearranging themselves.
Uh-huh. Yeah, that's a good analogy.
So besides the vastness of the environment,
Yeah.
what other challenges stand out in the world of MRL?
Another big one is dealing with delayed and sparse rewards.
Delayed and sparse rewards. What do you mean by that?
So in a single-player game like Snake,
Mm-hmm.
the feedback is immediate.
Right. Eat a fruit, get a point.
Exactly. But in a team-based game,
Make a MOBA.
yeah, the reward might not come until the very end,
Oh, I see.
after thousands of individual actions and decisions.
So it's like working on a project for months and only finding out if it was successful at the very end.
Yeah. And that can make it really hard for the AI to learn.
How so?
Well, the reward is so far removed from the actions.
Yeah.
How does the AI know what it did right or wrong?
That's a good point. It's like, how do you know if that one little thing you did back in week 3 actually contributed to the project's success or not?
Exactly. And that can make it really hard to stay motivated to keep learning.
So how do researchers deal with that problem?
Well, it's all about clever reward design.
Oh,
They're trying to find ways to provide more frequent intermediate rewards.
so it's like giving the AI little milestones along the way.
Exactly, to keep it on track and let it know it's doing something right.
Makes sense. Can you give me an example?
Sure, like in Dota 2,
Yeah.
instead of only rewarding the team for winning the match,
It should take a long time.
yeah, you might also give them points for achieving smaller objectives,
Okay.
like destroying an enemy tower
Oh, I see.
or successfully ganking an opponent.
So it's like breaking down a complex task into smaller, more manageable steps.
Yeah, with each step having its own little reward.
I like that. It's like a little dopamine hit for the AI.
Yeah, something like that. But there's another layer of complexity here that we haven't even touched on yet.
Oh, what's that?
Teamwork.
Oh, yeah. That's a big one in MOBAs.
It is. And it's one of the most challenging aspects of MRL,
I bet.
especially when you have both cooperation and competition involved.
Because you want your AI agents to work together,
Yes.
but you don't want them to become completely selfless either.
Right. You don't want them to sacrifice their individual performance for the sake of the team.
It's like that saying, teamwork makes the dream work,
Yeah,
but only if everyone's pulling their weight.
exactly.
So how do researchers tackle this challenge of balancing cooperation and competition in MRL?
Well, one approach that they mention in the paper
Yeah.
is to use something called a team spirit hyperparameter.
Team spirit hyperparameter. What is that?
It's basically a way to adjust how much weight the AI agents give to individual rewards versus team
Oh,
rewards.
that's interesting. So you can like
Yeah.
tweak how much they care about themselves versus the team. And by tweaking this team spirit hyperparameter,
Uh-huh.
they can try to find that sweet spot where the AI agents are both motivated to excel individually,
Yes.
but also contribute to the team's overall success.
That's the goal.
It's like finding the right balance between being a star player and being a team player.
Yeah. It's a delicate balance.
So we've covered some of the big challenges of Marl,
Uh-huh.
the vast environments, the delayed rewards, the tricky balance of teamwork.
Yes.
Now I'm dying to hear about how researchers are actually applying these concepts to real games.
Oh, yeah, that's the fun part.
Because the review paper you mentioned,
Yeah.
it mentions some amazing success stories, right?
Oh, absolutely. There are some truly remarkable examples of Marl in action.
Okay, so let's start with one of those success stories.
Okay, how about Quake the Reen Arena? Capture the Flag.
Oh, Quake the Reed Arena. Now that's a classic.
It is. And Capture the Flag, it's a perfect game mode for Marl research.
Why is that?
Because you have two teams trying to capture each other's flags,
Yeah.
so it requires a lot of coordination and strategy.
Makes sense. So what did the researchers do with Quake 3 Arena?
So the researchers at DeepMind,
DeepMind, yeah, they're a big name in AI.
they created these AI agents
Okay,
called FTW agents.
FTW agents.
Yeah, and these agents learned to play Capture the Flag.
Uh-huh.
But here's the thing.
What's that?
They learned solely from pixel data and game points.
Pixel data. You mean like the raw visual input from the game?
Exactly.
So they didn't give the AI any pre-programmed strategies or anything like that?
Nope. Just raw pixels and the points they got for capturing the flag.
Wow, that's amazing.
It is. And the results were incredible.
Tell me more.
So these FTW agents, they consistently outperformed skilled human players.
No way. Really?
Yes. They captured an average of 16 more flags per game than the humans.
Wow. Okay, so they weren't just good. They were like way better than the humans.
They were. And here's the really impressive part.
What's that?
They even excelled on brand new maps.
Maps they had never seen before.
Exactly.
So they weren't just memorizing strategies.
Nope.
They were actually learning how to adapt to new situations.
Exactly. That's what makes it so remarkable.
Okay, that's just mind-blowing. But Quake 3 Arena, that's a pretty old game now.
It is.
Let's move on to something a little more modern.
Okay. Like what?
How about StarCraft 2?
StarCraft 2, yeah. That's a good one.
That game is notorious for being complex,
It is.
with multiple races,
Mhm.
intricate tech trees,
Right.
a constant need to manage resources,
Yes.
and plan ahead.
It's a real-time strategy game.
Yeah. So how on earth did AI manage to crack this one?
Well, StarCraft 2 was a major milestone for AI in gaming.
I bet.
DeepMind, they developed an AI system called AlphaStar.
AlphaStar, okay.
And this system ultimately achieved Grandmaster level in the game,
Grandmaster level, wow.
which is like the top tier of players.
So it's basically as good as the best human players in the world?
Pretty much.
That's incredible. So how did they do it? What was the secret sauce for AlphaStar?
Well, it started with supervised learning.
Okay.
They trained AlphaStar on a massive data set of human gameplay.
Oh, so it's like they showed the AI a bunch of replays of expert players,
Exactly.
and that gave it a foundation of knowledge about the game.
Yes. Like the basic mechanics and strategies.
Okay.
But the real magic happened when they transitioned to reinforcement learning.
So they let the AI start playing against itself.
Yeah. And refining its skills through self-play.
Self-play. That's such a cool concept.
It is. It's like having a built-in training partner.
That's always pushing you to get better.
Exactly. And DeepMind, they actually took this concept to the next level
How so?
with their innovative league training system.
Lead training, what is that?
So imagine a whole league of AlphaStar agents,
Okay.
all constantly battling each other.
Wow.
Some agents focused on mastering the core game mechanics,
Right.
while others called exploiters.
Exploiter?
Yeah, they were specifically designed to find and exploit weaknesses in their opponent's strategies.
Oh, so it's like having a built-in quality assurance team,
Haha, yeah, something like that.
constantly testing and challenging the limits of the main AlphaStar agents.
Exactly. And the result of all this intense training,
Yeah.
AlphaStar became a force to be reckoned with.
It did.
Oh, yeah. It was able to defeat professional StarCraft 2 players,
Wow.
demonstrating a level of strategic thinking and decision-making
Uh,
that was once thought to be exclusive to humans.
that's just incredible. And I guess that brings us to our final game,
Yes.
Dota 2.
The king of
Yeah,
MOBAs.
Dota 2 is huge.
It's a global phenomenon,
Millions of
a
players.
massive esports scene.
It's hard to even comprehend the complexity of that game.
It is.
So how did AI fare in this challenging arena?
Well, Dota 2 presented its own unique set of challenges.
Like what?
I mean, first of all, it has a massive roster of over 100 heroes,
Yeah.
each with their own unique abilities and playstyles.
So the number of possible combinations is just mind-boggling.
It is. It's a combinatorial explosion.
So how did the folks at OpenAI
Yeah.
even begin to tackle such a complex game?
Well, they took a strategic approach.
Well,
They focused on a subset of 17 heroes.
17 out of over 100.
Yeah, they had to narrow it down to something manageable.
I guess so.
But they chose heroes that represented a diverse range of roles and playstyles.
Okay, so they were still trying to capture the essence of the game.
Exactly. And then they developed this sophisticated neural network architecture,
Okay.
utilizing a type of artificial memory called LSTM.
LSTM. Can you explain that a bit more?
Sure. LSTM stands for long short-term memory.
Oh, okay. That makes a little more sense.
It's a type of recurrent neural network
Uh-huh.
that's really good at remembering information over long periods of time.
So it's like giving the AI a memory boost.
Yeah.
So it can remember what happened earlier in the game
Uh-huh.
and use that information to make better decisions later on.
Exactly. And this was crucial for Dota 2.
Because the game is so long and complex.
Yes. There's so much to keep track of.
Okay, so they focused on a subset of heroes.
Mm-hmm.
They used LSTM to give the AI a better memory.
Yes.
Anything else?
Well, they also threw a truly mind-boggling amount of computing power at this problem.
I bet. How much are we talking about here?
The equivalent of 45,000 years of Dota 2 gameplay.
45,000 years. How is that even possible?
They compressed it all into just 10 months of real-world time.
Wow. So they basically created a time warp for AI training.
Uh-huh. Yeah, something like that.
And all of this led to the creation of OpenAI 5,
Yes.
which is their AI system for Dota 2.
That's right. It's a team of 5 AI agents, each controlling one of the selected heroes.
And how did OpenAI 5 perform?
Well, they made history.
They did?
They defeated the reigning world champion Dota 2 team OG.
No way.
You're kidding.
I'm serious. It was a stunning upset.
At the international tournament.
The biggest Dota 2 tournament in the world.
Wow, that's just incredible. So we've seen AI conquer Snake, dominate Quake the Third Arena,
Yes.
reach Grandmaster level in StarCraft 2.
That's right. And even defeat world champions in Dota 2.
It's amazing, isn't it?
It's mind-blowing. It seems like there's no stopping this AI revolution in gaming.
It's truly an exciting time to be following this field.
It is. But it's important to remember
What's that?
that superhuman performance is just one aspect of this story.
You're right. There's so much more to it than just beating humans.
Exactly.
Mm.
So what else is there? What other possibilities are we talking about when it comes to AI and gaming?
Well, that's what we'll be exploring next. It's about shifting our focus from simply winning
Okay.
to exploring how AI can enhance the player experience in entirely new ways.
That sounds intriguing.
It is. It's about AI becoming a partner,
Okay.
an opponent,
Uh-huh.
and a collaborator.
I like that. It's not about replacing human players.
No,
It's about AI making games more fun and more engaging for everyone.
exactly. And that's just the tip of the iceberg. These advancements, they have implications beyond gaming as well.
Oh, really? Like what?
Well, think about self-driving cars, for example. They need to navigate complex environments,
Right.
make split-second decisions, anticipate the actions of other drivers
It's basically a real-life video game.
with much higher stakes.
Yeah, that's true.
So the same MRL algorithms that power those Dota 2 bots,
Uh-huh.
they could be used to train self-driving cars that are safer,
Okay.
more efficient,
Yeah.
and maybe even less prone to road rage.
Uh-huh. That would be a nice bonus.
It would. But it goes beyond just self-driving cars.
What else?
Robotics is another huge area.
Oh, yeah, I can see that.
Imagine robots that can work collaboratively in warehouses
Okay.
or disaster zones
Uh-huh.
or even on other planets.
Oh.
The coordination and problem-solving skills that AI agents develop in games like StarCraft 2,
Yeah.
they could be invaluable in these real-world scenarios.
It's amazing to think about
It is.
how the lessons we're learning from training AI to play games
Mhm.
can have such a profound impact on the real world.
It's like we're unlocking a whole new toolbox of solutions to some of humanity's biggest challenges.
It's exciting and a little bit scary at the same time.
Yeah, I know what you mean.
But ultimately, I think it's a good thing.
I agree.
So where do we go from here?
Well, that's a question for next time.
Oh, right. Uh-huh.
We've only just begun to explore the amazing possibilities of AI in gaming.
And beyond.
Exactly.
Okay. Well, I'm definitely looking forward to that.
Me too. It's going to be fascinating. It's really fascinating how these AI agents, they learn all these skills in these virtual worlds.
Yeah.
And then we can actually apply those skills to real world problems.
Yeah, like what kind of skills are we talking about here?
Well, resource management, for one.
Resource management.
Yeah, it's a critical aspect of a lot of strategy games.
Oh, yeah, for sure. Like in StarCraft.
Exactly.
You know, you're constantly having to balance
Right.
mineral and gas collection, unit production tech
You
upgrades.
can't just build a massive army.
Right. You got to think long term.
Exactly. You got to think about the economic consequences.
And it's not just StarCraft.
Right.
I mean, that same principle applies to so many real-world scenarios.
Oh, absolutely.
Like managing a power grid, optimizing supply chains, even planning a city's infrastructure.
It's all about resource management.
You're saying that AI could help us with that?
Well, the AI agents that excel at resource management in games,
Okay.
they could provide valuable insights and
Okay.
potentially even solutions
That's pretty cool.
to these complex real-world systems.
Well, it's not just about the specific tasks that AI learns in games.
Yeah.
It's about the underlying cognitive skills that it develops.
Exactly.
And those skills can be applied to all sorts of different problems.
That's right. And you know, that actually brings us to another really interesting area
Okay.
where AI in gaming is making waves.
With that.
The study of human cognition.
Human cognition.
Yeah. By observing how these AI agents learn to strategize, cooperate, compete, we can actually gain insights into our own decision-making processes.
That's a fascinating idea. So by studying AI, we're actually learning more about ourselves.
In a way, yes.
How does that work in practice?
We'll take the concept of bounded rationality, for example.
Bounded rationality. I'm not familiar with that.
It's an idea from behavioral economics.
Okay.
And it basically suggests that humans, we don't always make perfectly rational decisions.
Okay, that makes sense.
Because we have limitations in our cognitive abilities.
Like we can't process as much information as a computer.
Right. And we don't always have all the information we need.
Yeah, that's true.
So we have to rely on heuristics.
Heuristics.
Like rules of thumb, mental shortcuts,
Oh, okay.
gut feelings, sometimes even a bit of luck.
Yeah, that sounds familiar.
So we're not like these super intelligent AI agents
Right.
that can calculate the optimal move in every situation.
We're a little more messy.
We are.
And you're saying that by studying how AI agents deal with similar limitations in games, we can learn something about how our own bounded rationality shapes our decisions in the real world.
Exactly. It's like we're using AI as a mirror
I like that analogy.
to reflect back on our own cognitive processes
And maybe even reveal some hidden biases or shortcuts.
that we might not even be aware of.
That's really cool.
It is. And it highlights the incredible potential of AI, not just to replicate human intelligence,
But to augment it?
exactly, to help us make better decisions,
Okay.
solve complex problems,
Yeah.
and even gain a deeper understanding of ourselves.
Okay, so we've talked a lot about the potential of AI.
We have.
But let's bring it back to gaming for a second.
Okay.
We've seen these incredible achievements. AlphaStar OpenAI 5
Yeah.
beating professional players.
It's impressive stuff.
But there's also this gap
There is.
between the cutting-edge research and what we actually see in the games we play every day.
Right. It's not like we're all playing against superhuman AI opponents yet.
Exactly. So why is that? What's causing this gap?
Well, I think one key factor is the difference in priorities.
Okay.
Researchers are often driven by this pursuit of superhuman performance.
Right. They want to create AI
Yeah.
that can beat the best humans.
Exactly.
But that might not actually be what's best for a game.
You're right.
I mean, if a game is too hard,
Yeah.
if you're constantly getting crushed by the AI...
It is going to have fun.
Exactly. It's like playing chess against a grandmaster. Sure, it might be a learning experience, but it's not going to be very enjoyable.
It can get old fast.
So superhuman AI might be impressive,
Yeah.
but it doesn't always translate into good game design.
That's a good point.
So how do we bridge this gap?
Well, it's a challenge,
It is.
but it's one that researchers and developers are working on.
Together.
Yeah. They're trying to find that sweet spot
Okay.
where AI enhances the gaming experience
Uh-huh.
without making it feel unfair or unenjoyable.
So it's got to be challenging,
Yes,
but not impossible.
exactly. It's a delicate balance.
So how are they doing that? What are some of the approaches they're taking?
Well, one promising approach is to focus on creating AI that's more human-like.
More human-like.
Yeah, instead of just optimizing for winning at all costs,
Okay.
these AI agents are designed to play in a way that feels more natural
Okay.
and engaging for human opponents.
So you're saying instead of trying to create AI that's better than humans,
Uh-huh.
we should be trying to create AI that's more like us.
In a way, yes. It's about shifting the focus
Okay.
away from pure performance metrics.
Like win rates.
Exactly. And towards creating AI that understands
Uh-huh.
and responds to the nuances of human behavior.
That's a really interesting idea, but how do you do that? How do you make AI more human-like?
Well, one technique that's gaining traction is imitation learning.
Imitation learning.
Yeah. Instead of programming AI agents with explicit rules or strategies, researchers are training them by having them observe human gameplay.
Oh, so it's like showing an AI agent a bunch of gameplay videos
Exactly.
and letting it figure out the patterns
Uh-huh.
and strategies that human players use.
That's the idea. By learning from human experts,
Okay.
AI agents can pick up on all these subtle nuances of gameplay,
Okay.
the strategic decision-making,
Yeah.
even the occasional blunders or creative plays.
Uh-huh. Right, because humans aren't perfect.
We're not. And that's
Mhm.
what makes us so unpredictable.
And you're saying that AI can learn that unpredictability.
That's the goal.
That's really cool. Are there any other techniques they're using to make AI more human-like?
Yeah. Another fascinating area of exploration is incorporating psychological models.
Psychological models.
Yeah. Like from the field of psychology
Yeah.
into AI agent design.
So what does that mean?
Well, for example, researchers are studying things like cognitive biases,
Right.
risk aversion,
Yeah.
even emotional responses.
To understand how those factors influence human decision-making in games.
Exactly.
So they're basically building in some of the quirks and imperfections that make us human.
That's right. Because we're not always rational.
Nope.
We make mistakes, we get emotional. And by incorporating those psychological elements into AI agent behavior, researchers are creating more realistic and believable opponents.
That's amazing. It's like they're giving AI a bit of personality.
Yeah. Making them less like cold calculating machines
Right.
and more like us.
So I guess the ultimate goal here
Yeah.
is to create AI that enhances the gaming experience.
Exactly.
It's not about AI replacing human players.
No.
It's about AI becoming a better partner, a more challenging opponent,
Yeah.
and a more engaging collaborator.
That's the vision.
Yeah.
And it's one that I think has a lot of potential.
Yeah. I'm really excited to see where this all goes.
Me too. It's going to be fascinating.
You know, it's really pretty amazing to think about how far AI has come in gaming.
Yeah, it really is.
From those simple games like
What's my snake?
yeah, Snake, exactly, to these crazy complex strategy games.
Like Dota 2.
Yeah, Dota 2 or StarCraft.
Right.
I mean, we've seen AI evolve from these basic algorithms
Yeah.
to these super sophisticated systems that can beat the best players in the world.
It's mind-blowing.
It really is.
Yeah.
And the crazy thing is, it seems like the pace of innovation
Yeah.
is only accelerating.
It's not slowing down at all.
So who knows what the future holds?
Yeah. It's really exciting to think about what AI might bring to the world of gaming in the next 5 or 10 years.
And as we've been talking about,
Yeah.
the implications of all this research,
Mm-hmm.
they go way beyond just entertainment.
Oh, definitely.
I mean, those lessons that we're learning from training AI to play games,
Yeah.
they can be applied to real-world challenges
Absolutely.
in all sorts of fields.
Like robotics?
Transportation, healthcare even.
Pretty much any field you can think of where you need to solve complex problems.
Because those skills that AI agents develop in these virtual environments,
Mm-hmm.
you know, the strategic thinking,
Right.
the problem solving, the adaptability,
Yeah.
even teamwork
Those are all incredibly valuable skills
in the real world.
in so many different contexts.
And I think for me, what's really exciting is the idea of using AI to enhance human capabilities.
Oh, yeah.
It's not about replacing humans.
Right.
It's about working alongside them
To achieve more.
to do things that we couldn't do on our own.
Exactly. It's about augmenting our intelligence, our
Yeah.
creativity.
And ultimately unlocking our full potential.
That's the real power of AI, I think.
Yeah, it's like having this super intelligent partner by our side,
Uh-huh.
helping us navigate the complexities of the world.
And who knows?
Yeah.
Maybe someday we'll even have AI systems
Yeah.
that can teach us new things.
That would be amazing.
Expand our knowledge,
Yeah.
our understanding in ways that we can't even imagine right now.
So we've gone from teaching AI to play Snake
Yeah.
to potentially having AI teach us new things.
It's crazy how far we've come.
It really is. Well, I think that about wraps up our deep dive for today.
It does it.
We've covered a lot of ground.
Well-
Learned a ton about AI and gaming.
And beyond.
And I, for one, am incredibly excited about the future.
Me too.
So to all our listeners out there, thanks for joining us on this journey.
Yeah. Thanks for listening.
We hope you learned something new
We hope you enjoyed it.
and that you're as excited about the future of AI as we are.
Just because it's going to be wild.
Absolutely. So until next time, keep exploring, keep questioning, and keep playing.